Good morning. Welcome to geometry class. From this week, our topic is about chords and arcs. This is from 12-2, textbook pages 771 to 778. I want you to prepare the following: your geometry textbook, your pen, and your copybook. Before we start our discussion, let us watch this video.
Let's figure out which chords are equidistant from the center of the circle. To help us find this answer, let's start off by recalling a few pieces of information. Like, what's a chord? Well, when we're talking about a circle, a chord is a line segment in a circle with endpoints on the circle. So here we can see we have chord AB, chord CD, and chord EF. We're looking at 3 chords. Now our job is to figure out which of these chords are equidistant from the center of the circle, this middle point here. Well, what does equidistant mean? Equidistant means the same distance. So we're looking at these chords and we want to figure out which are the same distance away from the center point. And to help us figure that out, we actually have a theorem we can use. That theorem states that if 2 chords are congruent, or the same length, then they are equidistant from that center point. So all we need to do to find our answer is to take a look at these chords, figure out the length of each. Then, any that are the same length are congruent, and following that theorem, they're equidistant, or the same distance from the center point. So let's take a look at chord AB. Well, chord AB, we can see, is 5 centimeters in length. Now what about chord CD? Well, chord CD has a length of 5 centimeters. And if we look at chord EF, that has a length of 4.6 centimeters. Now, to figure out which chords are equidistant, or the same distance from that center point, we just need to take a look at those lengths and compare them. If any chords are the same length, then they are going to be congruent and equidistant from the center of the circle. Well, we can see that chord AB and chord CD are both 5 centimeters in length. That means they're congruent. And by that theorem, they're going to be the same distance away from this center point. And we can even test that. If we draw a perpendicular line from chord AB to this center point, and we do the same thing with chord CD.
In this problem, you will use congruent chords. In the diagram, circle O is congruent to circle P. Given that segment BC is congruent to segment DF, what can you conclude?
Think, why is it important that the circles are congruent? 2 circles may have central angles with congruent chords, but the central angles will not be congruent unless the circles are congruent. So angle O is congruent to angle P. Given as the figure, suppose you are given circle O is congruent to circle P and angle OBC is congruent to angle PDF. How can you show angle O is congruent to angle P? From this, what else can you conclude? I will give you 10 seconds to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. The answer is, since the circles are congruent, their radii are also congruent, and triangle BOC and triangle DPF are isosceles. So line segment OB is congruent to line segment OC. This is also congruent to line segment PD and is also congruent to line segment F. Since angle OBC is congruent to angle PDF and the triangles are isosceles, angle B, angle C, and angle D, and also angle F are congruent. So triangle OBC is also congruent to triangle PDF by AAS. So angle O is congruent to angle P by corresponding parts of congruent triangles are congruent. And line segment BS or line segment BC is congruent to line segment BF. Within congruent circles, congruent central angle.
In this problem, you will find the length of a chord. What is the length of segment RS in circle O? What do you know? The diagram indicates that the length of segment PQ equals the length of segment QR, which equals 12 and 5/10. And segment PR and segment RS are each 9 units from the center. What do you need? You need the length of chord RS. So what's your plan? Segment PR is congruent to segment RS since they are the same distance from the center of the circle. So finding the length of segment PR gives the length of segment RS. You will need the information given in the diagram. Use the segment addition postulate to write an expression for the length of segment PR. Now substitute the lengths of segments PQ and QR. Then add. Chords equidistant from the center of a circle are congruent. So the length of segment RS is equal to the length of segment PR. Substitute the length of segment PR. So the length of segment RS is 25. Now grid your response.
Got it, number 2. Given us the figure, what's the value of x? I will give you 10 seconds to answer this question. Timer starts now.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Time's up. The answer is, since 18 plus 18 is equal to 36, the chords are congruent and they are equidistant from the center of the circle by the converse theorem 12-7. So the value of x is equal to 16. Great job!